In order to introduce factoring, we're going to look at these two examples. Here we have a division. Like we did in the last section, we're dividing this numerator by 3x squared, and we'll do that term by term. So first, 3x squared into 27x to the fourth, that would be 9x squared. And then 3x squared into 6x squared, that would be 2. All right, now we have the same numerator, and our instructions are factor. Now, factoring is like division, but you have to determine what to divide by, and basically we want to divide by the largest, in this case, the largest monomial that we possibly can. So we'll start with the coefficients, and we ask ourselves, what can we divide into 27 and also divide into 6? So the answer is 3. 3 is the largest number that goes into both. So we'll put that down. And then we ask ourselves, what's the largest power of x that divides into x to the fourth and into x squared? And that'll always be the smaller power. The smaller power divides into both. So we'll put x squared over here. So that's how we determined what we're dividing by. We're dividing by the largest possible monomial, more or less. All right, and now we say, okay, 27 divided by 3 is 9. And x to the fourth divided by x squared is x squared. 6 divided by 3 is 2. And x squared divided by x squared is 1. We don't have to write that. 2 times 1 is still 2. Now, the language that we use usually, however, is not divided by in this case. Usually we would say something like this. Let me redo this. Let's put our 3x squared on the outside. And we would say, all right, we have 27. We're pulling out factor 3. We're left with factor 9. We have x squared. X to the fourth. We're pulling out x squared. So we're left with x squared. And we have 6x squared. We're pulling out 3x squared. Or we could say we have 6, we're pulling out 3, we're left with 2. And here we have x squared, and that was pulled out. So that's the language that we use. Instead of divide, we say pull out in front. So let's look at number 1. I'm going to rewrite it. And what I like to do is I like to just put a little blank over here where we pull out what divides both. We call that the common factor, and we want to pull out the largest common factor. We call it the greatest common factor. So what's the largest number that divides both 12 and 15? Well, that's 3. Put that in front. And the largest power of x is always going to be the smaller one. Okay, so we put that in front. Then we say 12, we pull out factor 3, we're left with factor 4. 3 times 4 is 12. X cubed, we pulled out x, we're left with x squared. 15, we pulled out factor 3, we're left with factor 5. And x was pulled out. All right, so this is factored. Basically, it's division, or you could think of it as the opposite of a multiplication. Okay, in number 2, let's see what we should pull out in front. Here we have 24 and 18. The largest number that divides both is 6. Here we have x cubed and x squared. Just take the smaller power. Y squared and y, again, take the smaller power. All right, then we say 24. We pulled out factor 6. We're left with factor 4. X cubed, we pulled out x squared. We're left with x. And y squared, we pulled out y, so we're left with y. Now 18, pull out 6. We're left with factor 3. X squared was pulled out, and y was pulled out. Okay, so this is factored. We're going to be learning a few factoring methods. This method that we're doing now is called just what we're doing. Actually, it's called by the action that we're performing. We're pulling out the greatest common factor. Sometimes greatest common factor is abbreviated GCF. All right, let's do the next one. Let's do number 3. I'll put a blank here for what we're pulling out. Okay, 35, 15, we have factor 5 is the largest number that divides both. X to the 5th, x squared, just take the smaller power. Y cubed, y to the 4th, take the smaller power. Okay, 35, pull out factor 5, we're left with factor 7. X to the 5th, pull out x squared, we're left with x cubed. And y cubed is out. 15, pull out factor 5, we're left with factor 3. X squared is out. Y to the 4th, we pulled out y cubed, we're left with y. Okay, let's do number 4. Look at the coefficients, 24, 16, 4. We can pull out a factor 4 from all three. X, x squared, x, just put the smaller power down. Y4, y squared, y cubed, put down that smallest power, y squared. All right, 24, we pull out factor 4, we're left with factor 6. X is out. Y to the 4th, we pulled out y squared, we're left with y squared. All right, 16, we pulled out factor 4, we're left with factor 4. X squared, we pulled out x, we're left with x. Y squared, we pulled out y squared. Okay, 4 is out, x is out. Y cubed, we pulled out y squared, we're left with y. Okay, number 5, we have coefficients 5, 15, 25. We can pull out factor 5. Here we have the powers of a cubed, a to the 4th, a cubed. We can pull out a cubed. B cubed, b, we can pull out b. Okay. Let's see, we have 5a cubed, b cubed, we pulled out 5, a cubed, we pulled out a cubed, b cubed, we pulled out b, we're left with b squared. 15, we pulled out factor 5, we're left with factor 3. 5 times 3 is 15. A to the 4th, we pulled out a cubed, we're left with a, and b is out. 25, factor 5 is out, so we're left with factor 5. A cubed's out, b is out. Let me just add one last simple example. Let's say we have 5x squared y plus 5y, and we pull out factor 5 from both. And we also pull out y from both. Okay, so here we're left with only, we pulled out 5 and we pulled out y, we're left only with x squared. And here's what I want to point out. What happens when we pull out the entire term? If we pull out the 5, we pull out the y, then we're left with 1. So that's what I want to emphasize here. We're left with 1, not 0. We need the 1 there because when we multiply back, we have to get this above. So when we multiply back, we just look at what happens when we multiply back. Here we have 5x squared y, and here we have 5y. If we didn't have the 1 there, we'd lose the 5y. So if you pull out everything, leave a 1.